So, good day. Today, I'm gonna report the late-outgrowth endothelial progenitors from the patients with coronary artery disease, endothelialization of confluent stromal cell layers. Patients with coronary artery disease or CAD are the primary candidates to receive small diameter tissue-engineered blood vessels or TEBVs. So peripheral blood-derived endothelial progenitor cells or EPCs from CAD patients represents a minimally invasive source of autologous cells from the endothelialization. So from a previous study that the human CAD EPCs are highly proliferative and express many of the hallmarks of matured and healthy endothelial cells. However, their behavior on stromal cells that comprise the media of TEBs has been not yet been evaluated. So in this study, the primary CAD EPCs or control human specific endothelial cells HAECs were seeded over confluent quiescent layers of human smooth muscle cells using a direct co-culture model. So the percent coverage, adhesion strength, alignment under flow, and generation of flow-induced nitric oxide of the seeded CAD EPCs were compared to that HAECs. The integrin binding profile of CAD EPCs was also evaluated over a layer of confluent quiescent SMCs. Direct comparison of our CAD EPC result on analogous co-culture studies with cord blood EPCs show that both types of blood-derived EPCs are valuable options for endothelialization of TEBVs. So for the results and discussion, so, in the previous studies, we demonstrated that a homogeneous population of late-outgrowth CAD EPCs can be isolated from the patient peripheral blood and cultured to display mature and fully differentiated ECs characteristics. So, the CAD EPCs are highly proliferative and exhibit a characteristic of the healthy ECs. So the CAD EPCs are positive from EC markers CD31 and CD105 and negative for CD133 and hematopoietic markers CD45 and CD14. We also showed that the layer of CAD EPC dramatically improve the patency of small diameter EPT-FE vascular grafts in the rat femoral artery model. So we also showed that the layer of CAD EPCs dramatically improved the patients of small diameter EPT-FE vascular grafts in the rat femoral artery model. So as you can see here, this is the expanded uh, polytetrafluorine fluoroethylene vascular graft or EPT-FE. So as you can see here, this is some application of EPT-FE shown in the figure labeled as letter A to D. So the adult late outgrowth EPCs as an endothelial source. So one of the primary concerns about the use of default adult late outgrowth EPCs and as an endothelial source is their rare. So occurrence in peripheral blood. So the CB EPCs have been favored by some because they are relatively abundant and high proliferative, likely due to increased telomerase activity. So the peripheral blood EPC isolation exhibit a success rate of approximately 50%. However, all successfully isolated CAD EPC cultures expanded to 10 raised to 7 cells over 3 to 6 passages. So the current study employed a direct co-culture model to examine whether the late outgrowth CAD EPCs were also suitable candidates for endothelializing small diameter TEVVs. So the direct culture model employed in the current study was used to characterize the attachment and growth of CVEPCs to layers of quiescent SMCs. So the table 1 directly compares results from their recent study publication on CAD EPCs and the current study with recently reported data on CV EPCs, mostly from the Trusky group. So all the CAD EPC and CV EPC studies use HAECs as control cells. This comparison indicates that the CAD EPC performed similarly to CV EPCs. So as you can see here, the CAD EPCs maintain stable attachment and a growth on confluent layers of SMCs over 1 and 7 days. The extent of the cell coverage increased the seeding density for CAD EPC and HAECs, and CAD EPCs exhibiting significant greater coverage over SMCs than did HAECs at 1 and 7 days when complete datasets were taken into consideration. So for any given cell seeding density. So however, there were no significant difference in CAD EPCs or HAECs on average except for SMCs seeded with 110,000 cells, CAD EPCs, HAECs for 1 to or 7 days, because a seeding density of 110,000 cells on 2 CAD EPCs resulted in 90% coverage on SMCs at both uh, 1 and 7 days. All subsequent co-cultures use this seeding density. Greater capillary-like network formation was noted after 7 days, 30,000 cells centimeter squared. So others have noted greater network formation with blood-derived EPCs on PLLA scaffolds or matrigel in the presence of perivascular cells such as MSCs. So in this figure, it shows the short-term supraphysiological shear stress studies, CAD EPCs or HAECs cultured over SMCs, so smooth muscle cells. So both CAD EPCs and HAECs exhibited greater than 90% attention when cultured over SMCs for 24 hours and exposed to a short burst of supraphysiological shear stress of 100 dynes centimeters squared. Uh, CBEPCs also exhibited a greater than 90% retention over confluent quiescent SMCs upon exposure to burst of. So this figure shows the fluorescent micrographs of CAD EPCs and HAECs after 48 hours of static culture or exposure to physiological shear stress. So the alignment in the direction of the flow is a key of characteristic of endothelium. So they have previously showed that the CBEPCs and CAD EPCs aligned in the direction of the flow were seeded over the fibronectin coat Teflon, which used to mimic the surface properties of EPTFE synthetic vascular graft surface. However, ECs are known to exhibit different adhesion characteristics over substrates of a softer modulus, such as the SMC's layer on the TEVP substrate. Furthermore, biological substrates such as monolayer of other cells have been shown to behave differently to passive substrate to similar modulus such as polyacrylamide and polyacrylamide gels. So therefore, it was important to evaluate the behavior of the EPCs over a monolayer of SMC in order to evaluate their potential as an endothelial source for TEVs. So, as you can see here from your left, this is the figure of orientation of A and elongation at B of CAD EPCs and HAECs on SMCs exposed to 48-hour of 15 dyne centimeter squared shear stress or maintained in static culture. So the ECs seeded over SMCs in static culture follow the alignment of an SMC layer, but the reorient toward the direction of the flow after long-term exposure to physiological levels of steady laminar shear stress. So both CAD EBCs and HECs supposed to physiological shear stress for 48-hour aligned in the direction of the flow, with CAD EPCs exhibiting greater elongation and alignment than HAECs. Neither CAD EPCs nor HAECs exhibited a change in area before or after exposure to long-term shear stress when cultured over SMCs. This was consistent with the results reported for CBEPCs cultured over SMCs. So they have shown previously that the CAD EPCs exhibit greater mRNA expression of crop-like factor or K1F-2 under flow than the under static condition. So when static conditions when seeded over fibronectin coated Teflon AF. So the increased alignment with the flow exhibited by the CAD EPC may be due in the part of expression of K1F-2. So in this the right figure shows the cell area of both CAD EPC and HAECs in the co-culture did not decrease with flow. This figure shows the nitric release of CAD EPCs under static versus flow conditions. So in the vascular endothelial cells secrete nitric oxide in response to fluid shear stress, which serves to promote flow-mediated vasodilation. So they have previously confirmed that the CAD EPCs seeded in the fibronectin-coated Teflon AF release significantly greater nitrite after 24-hour flow at physiological shear stress than under static condition. In the current study, nitrite production was directly measured as the representation of nitrite production due to the short half-life of nitrite in aqueous solution. After 48 hours of flow of physiological shear stress, average nitrite production of CAD EPCs increased from an average of 0.14 nanomole to 46 nanomole per million cells seeded. So a recent published study of nitrate production of CVEPCs seeded on fibronectin coated glass showed that the CBEPCs produce approximately 20 nanomole nitrite per million EC seeded after 48 hours. So this figure shows the integrin blocking indicates functional CAD EPC's binding mechanism. So the CAD EPC addition over confluent quiescence SMCs were significantly blocked by antibody solutions against A5B1 and AVB3 integrins alone, and by combination of antibodies against A5B1 and AVB3 integrins. So this behavior is similar to that exhibited by HAECs, CBEPCs, and HACECs have also exhibited binding to fibronectin-coated surface that was dependent only on the AVB3 and A5B1 integrins. These results further demonstrate that the EPCs isolated from the CAD patients exhibit healthy ECs behavior. So finally, the CBEPCs was made attractive due to their potential for allogenic transplantation. Though it is important to note that the CBEPCs are not immunocompetent, late-outgrowth EPCs from the rat peripheral blood elicited substantially less alloimmune reaction than the rat aortic ECs. However, a comparison of CBEPCs and human umbilical endothelial cells or HUVECs from the same patient found that the CBEPCs express the same pattern of class 1 and 2 MHC molecules as HUVECs, indicating that they would likely be rejected in the case of allogenic implant without matching MHC types. For this reason, alone, use of CAD-EPCs as an autologous endothelial source may be preferred to avoid potential immune rejection. So for the conclusion, the CAD-EPCs exhibit confluence over SMCs for 7 days and maintained a confluent layer more effectively compared to HAECs attached to SMCs within 15 minutes and remained strongly adhered and exhibited greater alignment with the flow compared to HAECs. So these results were essentially equivalent to that observed for CBEPCs addition on SMCs. CAD EPCs exhibited binding dependence on the A5B1 integrin on confluent quiescent SMCs, as did CBEPCs. These results demonstrate that the peripheral blood EPCs isolated from the CAD patients may be a viable source of autologous endothelium for use of TEBVs.